going. This is indeed the Y4SD, and I want to, of course, mention the organizing partners, Connecting Dreams Foundation, the Global Network for Sustainable Development, Helping Hand International, and of course the MasterPeace Foundation, whose office I seem to be virtually in, possibly. Let's see if any of this is real. Oh, I didn't manage to prove anything. Welcome, welcome. You know, this event, the Youth for Sustainability Dialogues, happens every 2 weeks. And every 2 weeks we take a SDG and we dive deeper into it, and we bring panelists who work on that very subject. Today we are on SDG-6, tackling the global water crisis. And we have a great panel, and we also have an expert joining us today. For those of you not familiar with the format, the expert who will also present will also listen to different panelists presenting their work and be able to ask questions as well. I want to start by acknowledging today's expert. We have the pleasure of having Dr. Anand Kumar of the School of Management Studies, Nalanda University. Greetings, Anand. Welcome. Hopefully, I have so many people on my screen. I have to wave and hope that you're also. There we go. Yes. So welcome, and we look forward to checking in with you throughout today's session. And of course, the grand finale will indeed be you speaking with us about your work. I also want to welcome our wonderful panel. From the organization Say Earth, we have Ramveer Tanwar and Mohit Relan. Hi, Ramveer, Mohit. And from India Book of Record, R&D in charge at PC Polytechnic in Pune, Vishal B. Patil is here. Hi, Vishal. I said hi to you before, but now I do it in public. It's different. But nice to have you all with us. And like I said, after each of your panel presentations, we'll also have a chance for questions. So without further ado, what I'll do now is pass the stage, as it were, to Ramveer and Mohit. By all means, take it away, gentlemen.
Thanks, Mark, for giving this opportunity to our team to present our experience and our views with all the viewers. So me and Ramveer, we are working for Say Earth. Say Earth is an NGO that we founded last year. So me and Ramveer are the founders for the organization called Say Earth. It is primarily working on the lake and water conservation, and now we have also pitched into environment conservation. The total objective that we are focusing on is to maintain the hydrological cycle of our country and to restore the depleting water table that we have for our ecosystem. Next slide, please. So I'll just quickly go through some of the key issues that we all have been witnessing nowadays. One is the water hyacinth and the algae that we quite often see in the ponds. There's a lot of solid waste and the sewage waste that directly is being dumped into those ponds. The silt comes in, and the encroachment is one of the bigger problems, which is done not even by the general public, but even by the government departments. Next, please. So how we can solve these problems? So how we have been addressing these problems is we have been suggesting for some rooftop harvesting system, wherein you can just store as much water as you can as and when the rain falls. We also suggest using of STPs, but definitely not the mechanical ones, but the natural ones, which we'll be covering in the subsequent slides. Next one is solid waste management, which is a key thing that once managed will help not only in resolving the issues that we are facing with ponds, but also in the overall pollution level that has been spiking like anything throughout the world. So once we are able to manage our waste, I think we are able to manage the entire problem of the pollution. The only thing that I would request here is what we have also been following now is Catch the Rain campaign. It's an initiative by Government of India. I would request everyone to connect through that campaign so that catch the rain wherever it falls, whenever it falls. Next, please. Can we have the next slide, please? So basically what we have covered is what are the problems with the water bodies, what are the basic solutions. Now I'll just quickly cover on what we do, what is the process we follow. So basically, even before we start the work, we basically identify a water body. You probably have to go back to one slide. We identify a water body, we try to understand who's the owning authority, we visit the site with them, we take the necessary approvals, then we create a plan, we propose that particular plan to the concerned authorities or to the corporates, so that we can get the necessary funding from the partners, from the authorities, and then we start the execution of our activities, which includes removing all the weeds, creating earth excavation, creating pits for the filtration process, and even the landscaping. So once the entire water body is ready, we hand it over to the concerned authorities. And to make it sustainable and maintainable, we also propose aquatic farming in all the water bodies that we have been currently reviving. How we do is what basically covers on the entire process, how we started and how we completely hand over the pond. So Jal Chaupal is one of the initiative which was started by Ramveer Tanwar. So Jal Chaupal is nothing that other than a water meeting wherein we ask all the village community people or the local communities to come together to understand the importance of water, to provide their valuable inputs so that they can understand and we can create a connection between the people, the locals, and the water and the entire ecosystem. Because just going over there, digging the ponds and moving out of it without creating a connection, you are just kind of creating a hole. And that hole is nothing but a graveyard for everyone, for the entire ecosystem. So we started an initiative called Jal Japal, bring all the people together, bring the community, create a connection, tell them sensitize them, tell them the importance of water, how it's going to help them out, create a biodiversity out of it, and that's where we start and we create a sense of belongingness. And then once we feel that yes, the belongingness is achieved, then we start the actual work of cleaning a water body, rejuvenating it, creating multiple pits. For the filtration process, we can use bioremediation or constructed wetland. These are the natural methods we use. Alongside, we are also promoting afforestation by creating urban forestry and small nurseries of primarily, I would say, the medicinal plants. And then even to promote the environment awareness, we have been doing some nature walk, wall paintings, and even creating valuable products out of the waste. And as I said, to maintain and to sustain a particular water body, we promote the organic farming, eco-village, aquatic farming. Next, please. Next, please. So this is what I have covered. This is the basic process flow that we always advise. So one of the other
Hello.
initiative which Ramveer started was using social media. So we all are very much fond of taking selfies nowadays, right? Isn't it? So that's exactly what we used, because me or Ramveer cannot go and visit all those thousands of villages in small amount of time, right? So what he thought is, why not use social media for that? And why not identify those people, those enthusiasts of environment who want to do a change, who want to bring a change, who want to contribute towards their community. So we just ask them, go towards a nearby pond that you must have visited or your parents or grandparents must have witnessed in your nearby vicinity. It could be a village or a community. Take a selfie, post it, and let us know how it looks like now, so that whenever we get an opportunity, whenever we get a sponsor, or whenever we are able to propose it to somebody, we know, yes, this is the place where we have a water body. These are the people who are enthusiastic about it and reviving it. Next, please. This particular campaign, Selfie with Pond, was basically something which we thought might get some attention, some attraction for people. It was a fun activity, but surprisingly, it, I would say, expanded like anything, and it crossed the international boundaries, and more than 9 countries have supported this initiative. Nearly 1 lakh people have supported this initiative. This is one of the examples, I would say, like, in fact, 2 examples of what we have done in our rejuvenation process. First one is just converting, removing all the hyacinth and bringing back the water body to life. The other one, which was a dried area herein, because the chambers were not present, so there was not a drop of water coming in. So what we did is we created all those chambers. We created a channel wherein water can flow in, and this particular water body was revived in such a manner. Next, please. So this is another example. This is what I would say. This is one of the best examples that we have set for our country, wherein you can see we have used windmill, which is for the first time in our country. It has been used, a windmill being used in a pond for aeration system. This is primarily a German technology, but we have tried it in our country. This is something done near in Mohikala village, which is near to Chandigarh, Ambala. Those who knows that place. So what we have done is, after reviving the water body, the most important thing we all know, right? What it is, to have an aeration system, so that aquatic life can survive, so that the pond can survive for a longer period. So to maintain that oxygen level, the BO and DO level, and to give some life to the aquatic wildlife, what is going to be there, to have a good ecosystem, we wanted an aeration system to be developed here. When we did it, what we thought is, rather than putting a manual aeration system or something which is a mechanical, let's do something which is more environment friendly. And that's where we came up with this idea of having a windmill. So this is completely environment friendly methodology that we have used, using wind to create aeration system. Next one, please. This is, you can see how the bubbles are generating. It's a small video. Small bubbles you can see in the pond. So probably, yeah, we can skip in the interest of time. So this is another thing we have done. So as I said, most of the water bodies that we have, they have problem of water hyacinth. So after removing the water hyacinth, we thought that why not utilize this to form manure? Because plants, we all know, right? Plants, leaves, they are the best form of manure, natural form of manure. So we took out entire water hyacinth out of the water body. We stored it, we let it dry, which you can see in the second pic, and then we were putting it all together into the large pits, which you can see at the bottom picture. So these pits not only had the water hyacinth, which was dried up, but also has cow dung, which is the purest form of manure, along with some soil, so that it shapes up into a very good manure after few weeks. So within, I would say, 2.5 to 3 months, we were able to get very good manure out of it, which was purely natural. There was no chemicals or no uh, bioprocess that was involved. It was totally a natural method by which we have created this manure. Next one, please. Can we have the next slide, please? Okay. So I'll still move on. Okay. Yeah. So we are back. So this is another example. As I said, can you please go back? Yeah. So this is another example of what we have done. So as I said, we do not use mechanized uh, any mechanism. Basically, I would say we normally avoid using machines because they again add to pollution. So what we have done here is we have used constructed wetland method, which is purely natural. It uses natural forms to purify the water. That is all the sewage water, all the polluted water that is going to enter the water body. So instead of letting it directly enter into the water body and polluting again, we basically filter it by using 3-chamber process. The first chamber that we have is called a septic tank, wherein all the polluted water enters. There is a screening system which will stop all the inorganic and the larger waste outside it. All the silt, all organic waste is settled down by using the gravity, and then the flowing water is what we get to the second chamber. In the second chamber, we have sediments. We all know if anything passes through the sediments and sand, right, they will absorb some of the silts. Anything which is, I would say, organic material, that will be stopped there itself. So what we get as an output of the sediments and sand chamber is very clean water. Now, while the water appears to be clean, appears to be, I would say, colorless, but then it still has some polluted nutrients, right? So those nutrients, which is like, I would say, like nitrogen, phosphorus, right? Those nutrients may not be visible by naked eyes, but In order to absorb those so that they also do not enter the water body, we put phytorides, which you can see here. So these phytorides basically are put into the soil bed. So that soil is basically, I would say, it's not exactly a soil bed, it's basically a bed of sediments wherein all these phytorides are grown. The growth of these phytorides is through all those nutrients that are flowing through that sedimentation tank. Once they are passed through these phytorides, the output that we get, which is now getting into the pond, is the purest form of water, which is almost equivalent to a potable water. It is very healthy for aquatic farming. So that's what we have been doing, and we have been proposing to each and every one. So next one, please. So this is again a very small example that we have done. So we all know, like, certain kinds of grass are very helpful in reducing the soil erosion and removing the pollutants, right? So we have used vetiver grass over here in the ponds, and in the center pic you can see a nesting island. So this nesting island is what we have, this is a concept we have developed just to develop an ecosystem around a water body. It's not just about creating a water body, we have to create an entire ecosystem, right? So to develop that, we want aquatic life to grow and to sustain. And in order to have a sustainability in the aquatic life, we have created this nesting island wherein all the wildlife, all the aquatic life can safely lay down their eggs. They can relax, they can drink water. Even the migratory birds can come up, lay their eggs, and this is how entire ecosystem, the biodiversity, will establish. Next one, please. So this is one of the views you can see. Just an example of one of the ponds we have revived. You can see at the bottom there are two nesting islands. People are now walking across a water body wherein nobody used to even come up because there was so much foul smell that was coming out of it. Once it was revived, now there are a lot of tourists who are visiting the water body. Next one, please. So this is one of the examples. This is another, I would say, milestone for us, wherein this entire water body, which you can see left on the left side, which was completely full of silt and garbage, was converted into a beautiful pond. Once it was done, we got it successfully completed. We saw a motivation level was really high in the villagers. We proposed them that as a next step, now you need to move on to make your village an eco village. So for that, we asked them to start doing organic farming, which they did very fluently. Efficiently, they were able to grow organic vegetables. Once it was done, the next step was to bring the tourists, to bring the people who will buy their vegetables, who will start utilizing these ponds. So the next step was create a guest house, create a good landscape, put some boats in the water body, bring back our natural culture, put up some, I would say, traditional tools which will attract the tourists. So if you can go to the next slide, I'll be able to explain people better. So this is what has happened. So the same water body, if you can see, people are nowadays doing yoga. Visitors are coming. We are explaining them how the organic farming is establishing over there. You can see pottery is happening, which is bringing back the traditional lifestyle that we have, right? So all these are the things that we have brought back into a village which was basically deprived of all these wonderful things that can happen in a village life. In the center image, you can see what we have used is to serve the food. We have used organic plates. Everything which we have used is biodegradable. There is nothing that will pollute the environment. All the food that has been cooked here is made from the organic farms. So what you get here is an experience of lifetime. You get yoga to refresh your soul. You have a water body, a lake view. You have boats wherein you can do boating. You can enjoy a fresh meal, a very pure form of food, and you can enjoy our Indian tradition of pottery. So all these things you get into this abode, which we call as a eco village at Nankeri, which is near Saharanpur. Next one, please. So this is just about our team. So that's more about our initiatives, I would say. So at the end, I think we have Ramveer back. So probably I'll give a couple of minutes to Ramveer before we close. Thank you, everyone.
Hi Mohit, I'm audible right now?
Yes, Ramveer, you are.
Oh, thank you so much. During whole presentation, I was trying to speak again and again. So sorry guys, there was a technical problem when I started. So now I think it is resolved automatically when I reconnected the Zoom call. So guys, myself Ramveer Tanwar, who is an I'm environmentalist and TEDx speaker. So we just started this campaign when I was a student of my graduation in BTech Mechanical Engineer. So from my student life, we have just reached at this position where we are working in all over the India, in Haryana, Punjab, Uttar Pradesh, and in all over the districts and states. So we have a good team right now. We are just trying to join more and more youngsters through Jal Chopal, through Selfie with Pond, and through various such type of campaigns. So youngsters can join us, and we all can save our water bodies. We all can conserve the water. We can all conserve our environment together. So I think our time that was 10 to 15 minutes is over now. So thank you so much guys again.
Yeah.
Thank
And
you.
before we end,
Yeah.
before we end, if we can go to the last slide, I just want to reiterate one of the quotation that has been very popular. And this is something I think nobody should skip now because it's too late. Yes, it's absolutely bang on statement. We are the first generation to feel the effect of climate change, and we could be the last generation. So this is high time that we have to do something about it, because if not now, then when? So I would request everyone, guys, please pitch in. We have to get onto the ground and get things going. Thank you very much.
Thank you so much, Mohit, and thank you also, Ramveer. Despite the technical difficulties, it was great to have you here, especially within still the presentation. I think even in the chat, we're seeing some questions. I also want to get Dr. Anand ready to express any thoughts, observations, or questions. Before I do that, there is this, and I also see it coming in the chat, the question of the water hyacinth. Just keep it in mind. We can come back to it, but some people are asking about remedies for it. You started within the presentation on the water hyacinth. It was very present. And I think this is something quite global, actually, a plant that has some impact. So put that in your pocket. We'll come back to it. I'll turn now to Dr. Anand. So yeah, I lead you towards a question, but then I don't do the question. Dr. Anand, hello.
Hi, hello, and it was a wonderful experience for me to listening you guys. Your work is really wonderful, and we hope that you will get more and more success in future. And the topic which you have selected for your work is, of course, and as you already mentioned, is the need of this hour. And there are a few things which I also wanted to learn from you, actually. And that is how you have created the chamber to maintain the revival of that wetlands or ponds. So that's something why I'm asking it is, while you were presenting your work, I remember a few days back, I was visiting a nearby village. I stay in Rajgir, if most of you might be aware, or some of you might be aware, and it is in the southern part of Bihar. And when we talk about Bihar in India, it's basically, people perceive that it has a huge water availability in the state, because what we see in news is mostly flooded, and then, but if you see the distribution of floods and drought in Bihar, it's both of them are there. So in southern Bihar, mostly there is low rainfall, and then government came up with an idea to build these wetlands, especially ponds close to the villages. And what I have seen recently is they have invested the money, but there is not a single drop of water. But and if you see, still the summer is not started in this region. So we will discuss it later. Of course, I will be in touch with both of you that what can we do for this. But I just wanted to know about the chamber flow. What does it mean and how you constructed it? So that's one thing from my side.
Sure.
And then there are a few
you want me to take
after
up
this. Yeah.
Sure. You want me to take it up now, or are we going to do Q&A at the end of the session?
I would say if you want to briefly address it now, and then we'll, after a minute or two, we'll go on to the next panelist, and these discussions will come back at the end, I'm sure.
Yeah.
So, Mohit, on the subject of the chambers and how they're constructed. Of course, Ramveer also, if you wish.
Yeah, hi Mark. So that is a wonderful question and important also. So this is about chambers. So I think now in all the villages there are the some drains which just in drains flow the grey water or rainwater. So we just construct some 3-stage chambers at the inlet of pond, so that the waste water from the households, like people just wash their houses, so they just bath or they just wash their clothes, so that type of waste water come through the drains, small drains. Then we just construct some 3-stage chambers where we put some debris, where we put some aquatic plants which sucks the pollutants from the water, and debris which stops the garbage, and screening bar which stops the plastic and other rubbers, like that type of particles, and debris which stop the sand and the cow dung, like that of things to enter the pond. So now that wastewater is used, is to fill that pond, and which go through these chambers, and then it is filled the pond. So we were just talking about that type of chambers.
Okay.
So basically, what in technical terms, if I want to say, so basically it's a 3-chamber system. First one is called a septic tank.
Yeah,
okay.
I understand that.
Yeah. So it has a screening to stop all the heavy garbage. Then through the gravity, all the silt will be deposited at the bottom.
Yeah.
At the top, we will be having a lighter water, right, which will enter into the second tank, which will have the sediments and sand, which will basically going to absorb all the silt. Okay, once it passes, because sand, we all know, right, once you pass anything through the sand, what you get is a clear water. It may be polluted, but it will be clear in color.
Yeah, because of adsorbent and absorbent both.
Right, because it'll absorb all the silt, all the organic waste. Yeah, it'll absorb. Right. So in the third chamber, what we get is clear water, but it is still polluted. So to make it pollution free, we put phytoraids. So these phytoraids, these are plants which will absorb all those nutrients. Right. So those harmful nutrients are good for plants, right? For their growth, they need nitrogen. Right. So those nutrients are absorbed by those plants. And then what we get as an output of the third chamber is a very clear and unpolluted water, which we call as a treated water. And that's what is all this constructed wetland all about.
So thank you. I mean, can we discuss it right now, or you want us to discuss at the end?
We'll come back to it at the end. I would suggest, Dr. Anand, thank you, though. And indeed, there's more to discuss, but I want to make sure we have time. So I'll say for now, thank you, Ramveer, thank you, Mohit. And I'll turn it now to our next panelist, Vishal Patil. I want to hand the floor over to you, and the slides will come up as well. Welcome, and carry on, or your turn.
Thank you, sir. So hello everyone, I am Vishal Patil. I am from Maharashtra, India. So I am very grateful to the Connecting Dream Foundations for giving me this opportunity to share my work in front of you. Special thanks to Ashwi ma'am and Simiji for believing on myself. So let's start with the first. So all these numbers that you can right now see on your screen, so these are really thought-provoking. So because all we know that the water is as important as air for us. So moving to the next, here I have mentioned some reasons for water crisis and its remedies, out of which I am focusing on reducing I'm focusing on reducing the water pollution by cleaning the rivers as well as the ponds with the help of water hyacinth remover boat, which is my main project. Okay, so here you can also see that there are a number of reasons due to which water crisis situation is around created around the globe, and I would like to introduce about something about my work. So here I have mentioned some causes of river pollutions that I have found. That is industrial waste, sewage waste, mining activities, and due to the chemical fertilizers, means maximum utilization of the chemical fertilizers by the farmers. So due to that, the rivers are get polluted, and once it get polluted, the water hyacinth is growing rapidly. Okay, so this at the bottom of the side, you will see over here that this is not the picture of a ground. This is the picture of a Pauna river, Pune based. Means its complete basin is covered with the help of water hyacinth. So moving to the next, I have mentioned here 3 steps. So that if you follow these steps, then we can definitely clean our river basins. So first upon, stop the supply of polluted water source into the rivers. Okay. So if you are we are getting successful to stop the polluted water, then definitely the existing water automatically gets clean due to the natural flow. The next one is the make the source plastic free, means the whatever the source that you have, that rivers, ponds, or lakes, that we can make it plastic free or hyacinth free. Okay, so the main source for the development of hyacinth is polluted water. So once we cut it, then definitely we can able to remove the hyacinth easily, as well as we can stop the growth of the hyacinth. Then third one is the develop water treatment plant, so that we can utilize the water for the human uses as well as for the drinking purpose also. Okay, so as we all know that the water hyacinth is right now, the water hyacinth is become a very serious as well as the global issue. Okay, so this is one of the type of a crop specifically from subtropical of South America. So this crop is specially grown in within 23 to 30 days. Okay, there are 3 stages of growing the crops. First one is the primary stage within 0 to 10 days. Then next is the secondary, means 10 to 20, and last stage means in third stage they are growing rapidly, and doubling rate is near about within a 5 to 10 days. It will get double in size. Means maximum height over the surface is near about 1 meter. So these are some conventional methods that has been used by the governments, as well as some, as mentioned by the Mohit sir. So they are also gone through this process, that the physical removing of a water hyacinth. So this is one of the quite complicated process of removing the hyacinth from the river banks as well as from the ponds, because it consumes lots of money, as well as it requires efforts, and it's a time consuming process. And as I discussed earlier, the doubling rate of water hyacinth is only within a 20 days. It will get doubled in size, so that before reaching to the 20 days, we have to remove the hyacinth completely from the river. Otherwise, there is no usage of removing the hyacinth from the river. This is one of the chemical method, but it is quite dangerous for river, as well as means we can say that it is quite dangerous for human being as well as for the aquatic life also. So my objective is to develop the water hyacinth remover boat, which is completely run on the clean energy, that is known as a solar energy. So to minimize the contamination of water in plants, rivers, as well as lakes. Okay, so the main aim is to reduce the toxicity of water by removing the hyacinth plant and safeguard the aquatic life. If you are removing the hyacinth from the river bank, then definitely we will able to establish good aquatic life, as well as maintain the oxygen as well as BOD level of that particular water, and we can easily make this water drinkable, as means usable as well as drinkable for the human being. So this is my project on which since last 2 years I'm working. So solar operated water hyacinth remover boat. Here you can say it is India's biggest. Why I mentioned here the word India's biggest? Because no hyacinth remover boat in India that can collect the water hyacinth up to the weight of 2 tons. Means this boat is having the load carrying capacity of 4.5 tons. By considering the factor of safety, I have set the standard for the 2 tons only. So here is the project details. I would like to share with you that it is completely based on solar system. There is no any other source of energy were used, because I want to make it is pollution free. When you are going to use the mechanical hyacinths, then definitely there will be a running of normal engines, means IC engines, and once you clean the water, means you are removing the pollution from the water and you are polluting the air by using conventional methods. So here I am using solar energy for operating my boat. The front side, you can see that here the conveyor is attached for removing the water hyacinth, as well as my boat is specifically designed for the water hyacinth. But with the help of this boat, you can also remove the free floating objects, just simply as a plastic, thermocol, and any other oil layers from the water surface, so as to maintain the good oxygen contact, means good atmospheric contact of that particular water to maintain the oxygen level. Also, this I have also constructed one portable trolley, so that we can move our project, means move our boat from one place to another place. So once the work is finished from one point, we can move it to the another workstation with the help of simply by towing with the help of car only, as the weight of the project is only 800 kg. So this project is not only useful for the removing hyacinth and other particles, it can be also used for the flood emergency situations, means for example flood control. It is having the seating capacity of 25 passengers. So for this purpose also we can use this boat. So these are some advantages of the product. As I mentioned, it is completely runs on the green energy, means solar energy. So there is no need to there is no chances of any kind of air pollution as well as the water pollution. Why I mentioned water pollution? Because the conventional water hyacinths, which are hyacinth removers, which are available in the market, they are running on the hydraulic systems. So as there are some chances of leakage of hydraulic oil into the water surface. So as we know, the oil is a floating because the density is low than the water, so it covers the water surface and breaks the oxygen contact with the water. So this kind of situation will not be get arise if you are using my project. Then definitely I am using here less components, so that the maintenance and manufacturing cost is also gets reduced. And the most important thing is that according to the by consideration the width as well as the condition of the water hyacinth, as we know, once the water hyacinth cover any lake or any river, then there is no space for the movement of objects. So I have designed in such a way that it will take the turn around its initial axis without any another space requirements, as the conventional boat requires some space, or we can say that the turning radius is required for the movement of that particular boat. So here no such requirements, because it turns around its initial axis. The next one, here I have mentioned some kind of the specification for your information only. So here I want to mention that thing, that the total weight of the project, including the solar system, batteries, and all the components which are helpful for removing the hyacinth, the total weight of the project is only 800 kg. The water displacement, means the water displaced by the boat is 4.8 cubic meter, which is quite large as compared to the other projects. The load carrying capacity here I have mentioned, with considering the factor of safety 2, that is a 2 tons, and it is having battery backup up to 10 hours, and average hyacinth removal rate is around 500 square meters per day. Means if you are running this boat for 9 hours only, it can remove the water hyacinth up to the area of 500 square meters. Okay, but 500 square meter when it removes, when you are entering your boat in a primary or maximum up to secondary stage, because at the third stage the hyacinth the density of that particular hyacinth is quite large as compared to primary and secondary stage. So this rate quite will get reduced if you are introduce the project into the lake at the third stage of water hyacinth flow. This is the current state of my project. So due to the COVID-19 situations, I am unable to get tested actually into the rivers, because lots of permissions we have to take from the government, local government, that is a Pimpri-Chinchwad municipal corporation over here. So this is my complete boat. I mean, the project is completely ready to launch in the rivers. So this is the current status of my project. So the project is tested 3 times for the load of 2 tons externally as well as internally without hyacinth conveyor. And then project is tested for 7 times for the water leakage test. The project is built in such a way that every joint is covered by 3 to 4 layers of the metal sheet, so that once it is heated in the river, if any it is heated to the river bank or to the any stones or any other material, then it will not get leakage. So that for that we have also tested for several times also. So for proposal of joint collaboration is already submitted to the PCMC commissioner, and due to the COVID situations, we are not getting yet any responses from them, and we are filing the patent on the same, as well as the solar connections and motor testing is successfully executed. Why I mentioned, because the solar connection and motor testing is the heart of my project, because I'm running my project completely on a solar energy. So I think it's a great initiative for the concept of our Prime Minister, that is a Make in India. So I think if it is executed successfully, then definitely the all world that is facing the problems of hyacinth, as well as we can say the air pollution, which is completely removed. Okay, so that's it. If you have any questions, so you can ask.
Thank you. Thank you so much, Vishal. I mean, what a important and also very impressive progress you're making, important issue. Also in the comments where there's also discussions going on. I have before I turn to Dr. Anand, I have a little, let's say, a surprise for you. I want to welcome into this Zoom room. Can we have surprises on Zoom? I think so. Your mentor and guide, Amay Deshpande, is here. I'm looking for your expression of surprise, Vishal. And I wanted to invite him to perhaps leave a comment or ask you a question or anything for a minute or two here. Is Amay available? This is one of those moments where the revealing moments, like, aha. All right, we might get an opportunity, Amay, by all means, as we go in the next few minutes, raise your hand or leave us something in the chat. But he has been present in the Zoom, so you'll be pleased to know that, Vishal.
Oops.
I'll invite Anand now for the sake of time, and also to hear, Dr. Anand, your comments or a question for Vishal.
Yeah, so it is a great innovation, Vishal. So first of all, I want to congratulate you, because we are facing it, and water hyacinth is one of the major weed, aquatic weed, which is largely available in most of the wetlands in India and across the globe. So the one thing which I was more curious to know about was the cost, the total cost, and how and what is the expected life for one boat. I mean, this you can calculate, and this will add your advantage in your project. So that's something which is important for that. So that's
actually, sir, when I'm going started constructions, there is some kind of flexibility according to your requirement, means according to the capability of the customer, or you can say that government, local government, you can buy. Means the model is starting from the range of 10 lakhs to maximum up to 25 lakhs. Means the manual operated models to the completely automatic operated models, means you can control the boat with the help of remote only, with a range of 1.5 kilometers. Normally, the base model you can have, we are giving the battery life of 6 with a 5 years warranty, as well as the life of boat is near about 15 years.
Okay, great.
So thank you so much, Vishal, for your presentation, and best of luck with your work. In our last minutes here at the session, Dr. Anand, I'd like to give you the floor, and this time, instead of comments and reactions, by all means, speak with us.
Yeah. So you want me to share my screen first, and then, or somebody sharing? So let me share my screen with all of you, and I'll be talking about the information-driven approach to mitigate water quality challenges, especially. So why I have written it is information-driven approach to mitigate water quality challenges as my topic, is because I strongly believe that the information, the exact or correct information regarding the status of your water, either it's groundwater or its surface water bodies, is much more important in terms of management and to opt the exact or accurate management strategy for that aquatic body or for groundwater as well. And to start with, I will not go into the backgrounds and outline of my presentation. As mentioned by earlier, it was 20 minutes, but the time is less with us. So I'll be talking more about the work which I am currently doing in past 7-8 years of my life in research past. So all of know that how precious water is, and it is the core of sustainable development for all socio-economic activities and all the other activities of the globe. So I will just skip these slides first. Fast, and then so that we can have more discussion on the work. So if you see the major challenges, of course, I have listed a few, and I'll be talking about the water quality, but there are much more challenges which are facing the water across the globe. And then I'll just give you the brief idea about this paper, which was published in 2016. By McDonald et al. in Nature Geosciences, and this paper talks about the status of groundwater in Indo-Gangetic floodplain. And if you see these two images on the right, this one where you can see the cursor here, and then this one, these are the two images of this Indo-Gangetic floodplain, and then the right one with the red mark, you can see that image is taken from Ramveer et al. 2009. It was published in 2009, and it is the population density map of Indo-Gangetic Basin. And if you see this current paper, which I am talking about by McDonald and et al., they talk about that the population density of this basin is perhaps highest in South and Southeast Asia. If you can see, there are a few small areas where the population density is much higher than this Indo-Gangetic basin. But apart from that, this paper talks about the declining in water table along the Indo-Gangetic basin. However, if you see that the surface water bodies, especially two of the major rivers in India, it's Yamuna and Ganga, they both flow in this area along with their tributaries and other wetlands as well. So this is the status, and again they mentioned that every year it's 2.8 meters is the water level which is going down, and by 2018 2028 if you will be extracting water at a similar level, the scenario will be much more worse, because we are also considering the climate change in the climatic pattern, especially that area comes in, and some of this area comes under semi-arid part and arid part of the country. So I'll give you another background of this Indo-Gangetic basin. There are reports, there are papers which talks about the arsenic, fluoride, and nitrate contamination along this along the Indo-Gangetic basin. The groundwater are polluted. And if you see the occurrence of arsenic, you can see the health impacts of arsenic causes cancer, and then the fluoride, high fluoride causes fluorosis, dental fluorosis, skeletal fluorosis. Of course, nitrate, you might be aware that it causes blue baby syndrome, and then that baby will not survive for more than a few days or few weeks. Before I selected this study, which we conducted in Punjab, which is the part of Indus Basin, which comes under Indo-Gangetic part, Indo-Gangetic Basin. There were only two scientific papers which talks about the spatial distribution of arsenic in Indus River Basin, and both of those papers, they were published. One was published in 2005, and another was published in 2007, and both talks about the presence of arsenic in Pakistan. Again, if you see the Indus River Basin, which is the part of Indo-Gangetic Basin that I already mentioned. So three of the major rivers are in India, they flow in India, Satluj, Ravi, and Beas. However, other rivers, they are in Pakistan side. So when we started, there were only two papers, scientific papers, which talks, but the mechanism in terms of science, what they had described in that paper was totally different. They talk about, one of them talks about the arid environment causing some oxidation, and then there is leaching of arsenic in groundwater. Another talks about the anthropogenic activities leading to arsenic contamination in groundwater. However, if you see the scientific belief in majority of the South and Southeast Asian countries, what we perceive or what we believe exactly is like there is anoxic water condition due to high organic matter in aquifers. So that those papers were contradictory, and then we did our pilot survey. These green dots are the surveyed village which we surveyed in as a pilot village, and then what we found that they claimed that not only arsenic, but they are also having some bones and teeth-related disease, which was dental and skeletal fluorosis. So we altogether came up with an idea to test all three contaminants across the industrial basin in India and Pakistan. And then I'll show you we published that study in. And we included both the data from India and Pakistan and how these contaminants are especially distributed. But I will show you the Indian part. I will discuss more on the Indian part of the basin. And these are the villages which we had surveyed. Altogether, we surveyed 196 villages across the Punjab. You can see the northern part of Punjab. Some of you might be from Punjab, and you can identify this part. This is Pathankot. Just close to the Jammu Kashmir of India, and then you can see this is the Abor, which is the southern part of India, and this yellow line is the border between India and Pakistan. So we started from this, and altogether we tested 12,796 wells in these villages, and I will show you that how we have tested the villages. All these testings has been done based on these three kits. We used HEC fluoride test kit for the fluoride detection. We used ITS Econo test kit for arsenic detection, and we used chemistry kits for nitrate detection. And then we collected few samples, we analyzed it into the lab using IC and ICP-MS, and then what we found was that these kits are reliable enough to work in the field. Based on these findings, we used this kit, we selected these kits basically, and then I will show you the distribution. What we have found is like 70% of these untreated groundwater is used by the villagers for their drinking and domestic use. And if you see the distribution, what we have found in the Indian part of this basin is like there is very high concentration of arsenic on the northern part of the state, which is close to the Ravi River. If you remember the previous image which I had shown you, there are 5 rivers, and then the Ravi flows close to the border between India and Pakistan, and sometimes it acts as a border. So out of all 12,700 or approx 13,000 wells, what we have found is like 25% of these wells are not fit for drinking, and they are clustered along the Ravi floodplain. And I will give you one insight about that place is that there is a train which goes from Punjab to Ganganagar in Rajasthan, and that train is called as cancer train. So another contaminant which we included was nitrate. You can see there is a contrasting behavior of nitrate and arsenic, because the areas where we found high arsenic, it has very less nitrate. Apart these 2-3 villages, we have not found nitrate, high nitrate in that area. However, the other rivers like Byas, and this is the surface coming in, close to Firozpur, and then the southern part of the basin, they had very high concentration of nitrate in groundwater, which is again not suitable for drinking. Then fluoride, of course, we got very high fluoride close to Bhatinda and the other southern part of the state, and around 8% of the wells which we tested were high in fluoride, and it was not good for drinking. And of course, EC is again another thing which we tested in that area. So looking back to the depth profile, what we have got is like we have found arsenic across the depth up to 200 meters. We have found fluoride at the shallow wells. We have found high nitrate across the range up to 250 meters, and again the EC is on the shallow wells. So these are the wells these are findings which we found. And then I will skip these slides. I will just give you a brief about this slide that we also try to understand the underlying mechanism and how it is different from the other part of South and Southeast Asia. And this is the area where I work. I am more focused about. So this is these are the villages we selected for to understand the mechanism, and these are the points where we drilled boreholes, we collected the sediments, we analyzed the sediments in lab, we analyzed the sediments in field, and then we tested again. We retested these wells again, and then this is how we tried to understand the mechanism. So these are the again different steps. We used carbon dating, we used XRF analysis, XRD analysis, we used Zenes to understand the speciation of arsenic, to understand the aquifer conditions. So these are the things which I just escaped. But this is how we worked in the field. This slide I wanted to discuss, but it talks more about the mechanism part, which I don't want right now because of less time. But overall, to just give you an idea, is that the mechanism of arsenic contamination in particular in industrial basin is totally different from what we have observed in entire floodplain of South and Southeast Asia. So it's not at all anoxic. So the aquifers has enough oxygen in this basin, and that is what is causing high. That is what is somehow influencing the arsenic or the leaching of arsenic from aquifers sediments to the groundwater. So this is what these slides talks about. So I will skip these slides, and then coming back to the focus of this discussion is like the approach to reduce exposure. So when we published our paper, it was considered as as among the 10 most impactful studies conducted in 2018 in India, and then the government took attention to this study, and then they came up with a plan. Initially, they believed that there was no arsenic concentration so they retested their 9,000 wells in Punjab, and then they came up with three approach with the help of the World Bank. And then the approaches talks about the installation of new wells, one. The another talks about the surface water supply, another. Second, the third talks about the installation of RO system in the affected regions. So these are the three approach which government started, and then to mitigate exposure or to reduce exposure in these contaminated regions, they installed 2,327 reverse osmosis system in across the Punjab. And these these points on the map, they indicates that where these RO systems are allocated. And if you see there are huge numbers of household RO systems which are privately owned in that state. So these 2,300 RO systems, they are the community-based RO system. They used to sell water at very minimum price, 10 paise or 10 liters in 1 rupee or something like that. But if you see the allocation of these RO system, it is very surprising to see the allocation of this RO system. For me, if you remember, this was the high arsenic contaminated region, and you will hardly find any RO system installed in this area. So based on this, we can say that the installation of these RO systems were not appropriately done by the government, looking into the actual water quality scenario in that area. That is one observation. So the next is the next slide. Yeah. Then we tested a few RO systems, and what we have found is that we tested 108 RO systems out of these 2,000 approx 2,500 RO systems in that area. So what we found that 31% of these RO were insufficient. They were not working efficiently to remove all the contaminants. And out of these 108, 36% of these RO systems, the inlet water of these RO systems don't need any treatment because that inlet is already safe. So they don't need any treatment. So like if you combine both of these numbers, it's approximately 66% of these RO systems are either not adequate or either inefficient to remove or to provide safe water. So that's another observation from our study. So the next thing is what we have learned. What is the alternative approach to mitigate or to reduce exposure in this area is like we have not found out of 195 villages which we have tested in entire basin. And if you will allow me to include the wells which we have tested in Pakistan side. Altogether, we tested more than 500 villages, more than 30,000 wells in that area. We have not found a single village which has all 100% wells contaminated with any of the contaminants, which we have considered in this study. So our approach or our alternative approach is that when we are instead of putting all the efforts. And if you see the RO system, there again they need energy. They need what we are doing with the effluent or the wastewater which is coming out of it is again a major problem, because arsenic it gets accumulated in the soil, then it is coming into the food chain. That is another way of exposure. So our approach or what we are advocating right now is that if you somehow inform the community that where or the villages that where the safe wells are allocated in that area, they can go and take water from that safe wells. So that's the one approach which we are advocating right now. The another approach that we have found is, as I was mentioning previously, that we have drilled the boreholes, and why I have highlighted these two wells is like, this is the well. What we usually perceive in India is like when we go deeper in these alluvial floodplains, you get more clean or more safe water, but it is not the case in this river basin. Even if we are going deeper, some of the deeper wells are also contaminated, highly contaminated with arsenic. So that's something. What we tried here in a village which is called Makowal. It is close to Amritsar. It's like if you see this blue well, which we have marked as blue, and the green is between safe and unsafe. So if you see that the limits of arsenic in India, it was previously 50 microgram per liter. Then they deducted the limit and they bring it up to the WHO guidelines of 10 microgram per liter. So what we did is, how we have demarcated this. This is like the red ones are more than 50 microgram per liter of arsenic. Then the green ones are 10 to 50 microgram of arsenic. And then the ones are the safe ones. So this is how we have demarcated the wells. And these
hi Anand, I'm stopping you in between. I'm really sorry for this, but Anand already overshot our time by 10 minutes for the presentation. Can you please finish it off in another minute, and we'll have to, because the process is, the format requires us to close by 8:30. We've already crossed the time, so if you can just finish it off and in a minute, and we'll
yeah, sure. So what we are trying to say, what we have found here is that the sediment and the leachable arsenic concentration from the sediment. So what is the leachable arsenic coming from sediment? What we have found is in the shallow wells, there is less leachable arsenic. There is less sediment arsenic concentration in the sediments. And if you somehow reduce the depth of the well, and we tried to convince that person who was a well owner of this well, and then he reduced his well depth up to 20 meters depth, which this well was initially it was 50 meters deep well, and the depth, he has reduced the depth, and now still we did it in 2018 until today, that till last week we have tested this well, and it is providing safe water. So if you somehow inform the community that these are the safe wells close to you, then they can go and get safe drinking water. Similarly, in terms of surface water, we are using this water to cloud approach. We are using this approach to monitor surface water bodies to understand the pollution and from where these are coming. So in this part, what we are doing is we are working with cyber physical sensor networks. So, and for each of the parameters, we are collecting, we have sensors, we put it into the water, and then we collect quality data for each and every 10 seconds, and then we plot it on the Google Earth images and using GIS and other softwares. And you can see in at this slide that these are the points where you can see that the color is changing. For example, I have kept it for turbidity. So the turbidity is increasing at this point. Again, here we can see that there is some change in this parameters, temperature, electricity, DO, POD, COD, and nitrate we are measuring using this. And why it is changing here is because there is a jute mill outlet. This is a point source of pollution. There is a outlet from thermal power plant. Again, it is a point source of pollution. Then there is a boat point here, and there is a small drain coming in, and so that's how we are trying to inform the community that these are the areas where the water quality is not safe. This is taken from Triveni Ghat in one of the in West Bengal actually. So this is how we are working, and this is what I am more focused right now. Yeah. Looking into the quality, understanding the quality, and informing it to the people that that what type of measures they can take.
Yeah, thank you, Dr. Anand. And it's interesting how our journey has gone today here with the importance of monitoring and detection and the hard work behind that. And we began today with projects related to implementing, related to working in the communities. I see how these two go obviously very well together, but also what your data really shows is the urgent need, and to me anyway, the massive need, the scale of it, which is something quite, well, daunting, if I can be honest. But there we have it. Anyway, we are indeed out of time, so I do apologize, Dr. Anand. I can't open up the floor. There have been a few comments, and this is being recorded, so I would encourage anyone who perhaps wants to address in different formats online the questions that have been posed, the discussion, you can go back through this. I want to say a big thank you, Dr. Anand, for your presentation and also your participation today. I also want to say thank you to the panelists. Obviously, it was so interesting that we've gone over time, but that's also a sign of the importance of this issue and the amount of work that is required to really address this issue of access to water. So thank you to everyone. A big thank you to the core team of Y4SD. That includes Art Boss, Dr. Amit Tuteja, Dr. Sapna Narula, Dr. Simi Mishra, Dr. Ashima Mathur, Arshveer Kaur, Priya Gul, Dhruv Panchal, Valentine Perin, Vasu Gupta, and Vibhav, I shouldn't forget, for putting these sessions together, all the people that make this possible. I also want to say our season of Y4SD comes to a close on this note. Thanks so much for joining us both today and throughout. We will be back in some form. We're thinking about it. We're coming up with ideas. So by all means, keep up with any updates through social media. You know all the places, obviously Connecting Dreams Foundation and all your favorite social media, hashtag Y4SD. And I think on that note, I wish you all the best. Thank you very much. And let's hope for a better world. Let's work for it. I'll see you there. Bye, everyone.
Bye-bye.
Thank you, Richard.
Thank you, everyone. Thank you.
Bye, Mohit. Thank you so much. Great job.